Alright guys, here we go. It's final exam review time. And we're going to get started. Anytime during the video, if you need to pause it, just go ahead and do so that you can follow along. We're going to start with chemistry, of course, the first thing we learned. And I'm going to start by taking just a sheet of paper and making a foursquare so that I have kind of an area for each bit of my information. So I'm going to fold it, move this to the side, fold it again, and we're going to get started. Alright, so we are going to start with the atom. Draw my lines. They don't have to be perfect. I just want to know that everything is kind of separated here. So we're going to start with the atom. And as all of you remember, the atom has two basic parts. It has an inside, and this area is known as the nucleus. So I'll write that out to the side. And as you remember, the nucleus contains two types of subatomic particles. I hope you remember it contains the protons, which are positively charged, and it contains neutrons, which have no charge or are neutral. The neutral neutrons. Those two particles are going to be inside my nucleus. And the nucleus contains all of the mass of the atom. So if you want to know where most of the stuff is in an atom, most of the stuff is in the nucleus, because these are, remember, these are those larger particles, right? Protons and neutrons are larger particles. Let me get a couple of colors here. All right, so we are going to go ahead and do an atom of, let me see here. How about an atom of boron? It's going to be boron. And this is element number 5, or on the periodic table, atomic number 5. And boron has 5 protons and boron has 6 neutrons. So I'm just going to use the N for neutrons. So there is my nucleus of my boron atom. I think you might need a little bit. There we go. That helps. And then now we are going to draw the energy levels in the electron cloud. Boron has 5 protons, so it also has 5 electrons, meaning that I need 2 energy levels for my electron cloud, because the first energy level only holds 2. I'm going to draw my 2 energy levels in the electron cloud, and I am going to use a little dot for electrons. So 2 on the first energy level, and then 3 on the second energy level. That would be an atom of boron. So let's label this the electron cloud, and I'm going to shade it. It's light yellow, so you'll remember anything outside the nucleus is the electron cloud. So this whole area outside the nucleus is my electron cloud. And my protons were in green. And my neutrons I had done. And then the electron cloud. and it has those negatively charged electrons, which I've indicated with little orange dots. And it is shaded, the yellow part is the electron cloud itself. So we know anything outside the nucleus is that electron cloud. This area, the electron cloud, has almost no mass, but contains the majority of volume. Or space. It takes up more space. All right. So we're going to use this same example, and we are going to say, well, how did we get that information? So in our next box, let's go ahead and draw an element key for boron. So, element key. So we had to read the element key, remember? And that's how I got this information, and that's how you get it as well. So here it is. Not doing a very good job, I don't think, but anyway, it's 5. It's got the symbol B. The name is boron. And it's got 10.81 as a mass number. So let's label these areas. So this area right here, this is our 8th number. It's also known or labeled on your periodic table as the atomic number. Remember, this 8 number is called 8 because the atomic number and I'm going to use this sign for number. Atomic number is equal to protons and equal to electrons. That's why we call it the 8 number. So if I have 5 as an atomic number, then I have 5 protons and 5 electrons. So 5 protons and 5 electrons. Okay? That's why we nicknamed it the 8 number. All right, and we're going to look down here towards the bottom. This bottom number is also important. It is on the periodic table, they call it the atomic mass. We're just going to shorten that to mass number. So, we nicknamed this number man, and we did that for a reason. We said the mass number, we use the number sign for mass number, minus the atomic number, the 1 at the top, or the 8, equaled the number of neutrons the atom has. Okay, so this number minus the 8 number gives us neutrons. So we could say mass minus 8 equals neutrons. Okay, and that's where we got man. Mass minus the atomic number gives us the number of neutrons. Okay, the first thing we need to remember to do is first, in order to calculate neutrons, put that here, calculate neutrons. First thing you have to do is you have to round your mass number, or the mass number, or the man number. And if you round, our mass number is 10.81. This is the number that determines if you go up or down. Remember, 0 to 4. This was 0 to 4. You go no more, so it would stay at 10. But if it's 5 to 9 after the decimal, then the monkey climbs and you go to the next number. So my number is going to become 11. Okay? That's the first step. Then you want to, step number 2, then you need to do what? Subtract the 8th number. Or atomic number, either way. Remember, you can use a calculator to do this on the test. You are allowed a calculator.
You are released to go to the next class period.
So we have the mass number, 11. Subtract, minus the 8th number was 5, so minus 5. And that equals 6. And that is why I put 6 neutrons in the nucleus of the boron atom. So 6, 3, get the number of neutrons. Which are now 6 for beryllium. Remember that? Read. I hope you do. So now we also, of course, now remember what the ape stands for, the information it gives us, protons and electrons, and the man's net number lets us calculate how many neutrons are in an atom. All right, let's move on to box 3. In box number 3, we're going to review metals, nonmetals, and metalloids. And if you remember correctly, when you look at the periodic table, you can easily identify them. So we're going to do periodic table, metals, nonmetals, and metalloids. That's what we're going to look at now. So remember, if you remember correctly, the stair step on the periodic table is the magical dividing line. Remember that? So the stair step divides or separates metals from nonmetals. The metals are on this side, and nonmetals are on this side. And the metalloids touch the stair step. All right, so let's talk about characteristics.
6th graders, you should be in your class at this time. 7th graders, you are now released to go to the next class period.
So what are the main characteristics of the metals? Metals are conductors. They are very shiny, or they have luster. Remember, metals can be pulled into wires, and we call that they are ductile, or they have ductility. They can be made into wires. The metals are malleable, meaning they can be bent, hammered, and flattened like aluminum foil. All right. So that's pretty much the basics of the metals. You also need to remember there's one exception. And that is hydrogen is on the metal side, but it is a non-metal. So it is on metal side, comma, but it's a non-metal. Hydrogen is our exception. All right, what about those non-metals? Well, they're very poor conductors, could be considered insulators. Most are liquids or gases at room temperature. Gases at room temp. But if they are a solid, they are brittle solids. They have no luster. They're not malleable. They break apart easily. All right. And
5th grade, you should be in your class at this time. 8th grade, you are now released to go to your next class period.
the metalloids are kind of the weirdos. They contain characteristics of both metals and nonmetals. So they have characteristics of metals, nonmetals.
Miss Kidder, did you get my absence note from the office? Oh, well, I attended the...
So, hang on just a minute.
Yesterday, how I left your class early, I left the excuse of the
Yeah, that's fine, because I didn't mark you absent.
Okay.
All right, Olivia.
Thank you. Have a good weekend.
You too. All right, so metalloids have characteristics of metals and nonmetals, but we do have an exception here. The exception is aluminum. Touches stair step, but is a what? A metal. So aluminum, even though it touches the stair step, it is a metal. It is in this category of metalloids that you would find elements that are considered semiconductors. So these conducted well, these are poor, these conduct under certain circumstances. So we're going to write semiconductors. But just remember that aluminum is a metal even though it touches the stair step. Alright, so now let's go a little bit further and take a kind of another different look at the periodic table. I'm going to recommend that you all use your periodic tables that we created. And let me just show you what I'm talking about here. You will need to be using the one we did with metals, nonmetals, and metalloids. So this one is one of them that you should be using on the test. You can see it, where we color-coded them all and explained all their characteristics and all of the differences. And then another periodic table that you should be using would be the one we did on how elements react with one another or how they bond. Two periodic tables that I recommend you have. I am going to put these in with the review stuff so you can either print it out to utilize it or find yours so you know you'll need it for the exam. All right. So let's talk about the periodic table for a minute again. So if we just drew a little bit of the periodic table, and it's not going to be perfect, and it doesn't have to be, if we do something like this for our periodic table, and then we have those transition metals there, and then
Miss Kidder,
yes.
I have a question. Next, you know how you put in the Google Classroom, we have a makeup day? Makeup zero day
At
on
this
Wednesday
time,
next week?
all students
Will
should
we
be
have it
in
in
your
your class
classroom.
too, or will we be doing like work?
All classes.
Yes, ma'am.
All right, so we're just gonna, it's not the prettiest, but we're gonna pretend it is. I'm gonna draw a couple more, just so we have a little bit of an oversight here. So that's good enough there. Not beautiful, but it'll work. So that's my makeshift periodic table. Remember the rows, and they are numbered, so on. They're not numbered on the other side, but remember I always told y'all I would go ahead and number them so you don't get confused with what row you're on. It helps. So anyway, the rows are called periods. Right? The rows are the periods. And the periods tell us how many energy levels the atoms in that row have. So periods tell about the energy levels. Okay? So I know if I'm an element in period 3, I know if I draw it, I have a nucleus and 3 energy levels in the electron cloud. The groups are the ones that go up and down. So remember, we said there's the word up in group. Groups go up and down. So every one of these are a group. And groups are like families. They share similarities. They share the same number of valence electrons. They have similar similarities. And why do they have similar properties? Because they have the same number of valence electrons. So we're just going to put here valence electrons. That's their similar property that they all share. So every column is a group, right? The rows go across, the groups are the columns. The columns or the groups, they go up and down. All right, so when we look at this, we also know that there are certain metals that don't follow the rules of bonding. Remember, we said, first of all, there's one group that will not bond at all. So group 18 is the noble gases. They do not react or bond? They are stable or inert because this group is 8A, meaning 8 valence electrons. They have 8 valence electrons. Remember, 8 is great. And we know they have 8 because they are in column 18 and have 8A. 8A means valence electrons. That tells you how many, the A number. So they are stable or inert is another word for stable, remember? Meaning they're non-reactive. All right. I'm going to grab another sheet of paper to go through this. Y'all can flip yours over. I'm just going to do another one. That's going to make it easier for me to put notes in the folder for you guys. All right, I'm ready to go with the next one. Remember, you can pause it and do what you need at any time. So here is my next one. Okay, so let's talk a little bit more about bonding, or how groups bond. Remember, we have certain groups that want to bond with each other. So group 1, they have 1A, meaning they have 1 valence electrons. They want to bond with group 17 because they have 7 valence electrons. And group 2 with 2A want to bond with group 16, which has 6A. And then group 3 with 3 valence electrons. Since they want 8, they're going to bond with group 13, sorry. Remember, it's 1, 2, skip the transition metals, and then 13. So group 13 has 3 valence electrons. Want to bond with group 15 because they have 5 valence electrons. So all of these numbers, the A numbers, have to equal 8, right? And then group 14 with 4A will bond with group 14. This is the most basic way that elements bond. All right. And we said the noble gases will not bond because they already have. So the chemist says the number of protons. The chemist says 2 things. The number of protons right from the 8 number, same as the 8 number or atomic number, tells the identity of an atom. So meaning if you look at the 8 number, top number in the box, you will always know what atom it is because you look at that top number, like this one. What's yours? If you know 3 is the atomic number or the 8 number, or it's got 3 protons, then you automatically know that this must be lithium, right?
Students, please pardon this interruption for an important announcement from the counseling office. Teachers, the counseling department is diligently working on second semester schedules. You may see new buttons that pop up in your classroom online. Please do not process these new buttons.